There are some problems that may seem that they should be solved with a proportion, but in fact they cannot. So the question is, how can we tell the difference between problems that can and cannot be solved with proportions? Well, in order to look at that and figure that out, we want to look at another type of relationship, inversely proportional relationships. Let's start with a quick review of proportional relationships. In proportional relationships, quantities vary in a fixed ratio. So if I double one quantity, I also double the other. If I multiply 1 by 7, then I multiply the other quantity by 7. If I divide 1 by 3, then I must divide the other one by 3, and etc. However, there are other ways in which two quantities can be related. And although we might show the relationship in a table, not every table is going to be a ratio table that shows quantities in the same ratio. Some relationships that seem like proportional relationships at first glance are actually inversely proportional. Inversely proportional relationships are characterized by the fact that when one quantity is multiplied by a number, the other is divided by the number. So if I multiply 1 by 2, I must multiply the other by a half. If I multiply 1 by 7, I need to divide the other by 7, etc. So let's try to examine the difference between proportional and inversely proportional relationships. Let's suppose that it takes 2 people 8 hours to mow a 15-acre plot of grass. And we're going to consider an idealized scenario in which people mow grass at the same steady rate and work together at the same time to complete the job. Well, there are 2 kinds of variation that we might want to consider. First, if we vary the number of people, but keep the 8 hours fixed, how does the number of acres they mow vary? And 2, if I vary the number of people, but keep the 15-acre plots fixed, how does the number of hours it takes to complete the job vary? Well, let's start by breaking down what we do know about this problem. Let's suppose we have this 15-acre plot. We know we have 2 people, which is why I've split this into 2 pieces. So this here is going to be 1 person. This here is 1 person. And we know that this is each 7.5 acres. So each person is going to mow 7.5 acres in 8 hours. So if 2 people can mow 15 acres, then if we were to increase the number of people to, for instance, 4 times 2 people, we would be able to do 4 times 15 acres of land. So in general, n times 2 people will mow n times 15 acres of grass in 8 hours. So this tells us that this is always in the relationship in the ratio 2 to 15. So this would be a proportional relationship. So our first case of varying the number of people and seeing how it affects the acreage, we get that this is proportional. Next, let's think about varying the number of people and seeing how long it would take them to mow the 15 hours. Well, I'm going to start by making a chart. We know that if we have 2 people, it takes 8 hours, which means 1 person should take twice as long since they do twice the amount of work. Doubling the amount of people should reduce the amount of time in half. And then we can reduce it again and again. So this time, n times as many people result in 1 over n as long. So this is actually inversely proportional since it does not follow that constant varying rate. Instead, the n times people gives us 1 over n as long.